you see, we have 20 participants. Somewhere during the talk, I will share the attendance form for a limited time, so to make sure that everybody is online. This is a very important lecture, very interesting lecture for me as well. Okay. Without further ado, I would please give attention to Cik Hazika, and maybe you introduce a bit the background of the project you are doing, so that the students get the idea of what they are looking at. At the moment, the industry, I think the local scenario, we are not yet familiar with this concept of citywide planning simulation, but let's see if you can start thinking around this idea in a more preemptive way. Okay. Before that, I just need to remind you that you still have one IES workshop with Mr. Mahmood. Okay, and please let us know if you need assistance in terms of advisory on your project and your assignment that is on your final project. Okay, please discuss with Mr. Mahmood next week. That is his final workshop. So I leave the screen to Hazika. You want to share something before you introduce your thing?
Yes, Doctor. Okay, I have. Dr. Zaki, before I start, does the students actually familiar or know about IES softwares generally?
They have already had two sessions with a lecturer on IES. Okay. So they are aware of what IES is capable of doing. I hope everybody is aware. We already had 6 hours instruction. All right. So this is more or less similar to IES, but it has different scope and implications.
Okay. Okay.
I forgot to mention that Azika is with SERI, Solar Energy Research Institute. So she is doing
from UKM.
Sorry, UKM.
Yeah.
Bangsa Malaysia. She is currently doing her PhD. Which semester, Hazika?
Actually, master, Doctor.
Oh, master.
Semester 3. Yeah.
Okay. So, but she is doing master by research, right?
Yeah, correct.
With
indoor energy architecture.
With Dr. Lim Jin Hao. Okay. Okay, the screen is yours, Hazika.
Okay. I'll share my screen. Okay, so can everybody see my screen now? Yeah. Yes.
Still in PowerPoint. If you can share the whole screen, that would be better.
Yeah.
Now it's better.
Okay. All right. Okay, great. Okay, so I'll start my sharing session now, for today on introduction to Intelligent Community Lifecycle, ICL. Okay, so first and for all, I think you guys are quite not a bit familiar with IES, but today I will focus on a sub-softwares under IES. Okay, so IES is actually a digital twin technology for sustainable master planning. Okay, so the contents for today is first I will explain a bit on digital twin technology. So the digital twin technology is the main concept of why IES develop this ICL softwares. Okay, so second I will elaborate on the software itself, which is the ICL, and then the one a bit of actually demo lah, basic demo on how to operate this software, and then the last one is my research paper, case study on Bertam City. Okay, so first and for all, digital twin technology is actually a digital representation that accurately reflects a real world entity or system. So in a simpler form is an exact or almost exact copy of a real world entity, and then we will develop it in virtually along with all of its data and information from the physical world. So we can control the operations or any changes that we want to make from the virtual model. Okay, so this is a bit of application for digital twin technology. So in engineering sector, basically engineer use this technology to replicate the model of turbine. So it can like do some error system. They can detect some error system from the model turbine that they develop. Also the wind turbine, which is a bigger models of from the basic turbine before. So it also can check the risk and reliability of the wind turbine. Also remote condition monitoring, because as we know, wind turbine is located in a scarce area, right? So it can just do some remote condition monitoring from further. Also an oil rig also can do digital twin technology of an oil rig, and of course a city. So this is something quite new, especially in Malaysia. And further advancement in medical sector, they use digital twin technology to make a copy of human body or a specific patient, so they can diagnose disease or any viruses that has infect the patients. So this is actually very new, and there's quite a number of publications on this topic. A little bit of history of digital twin technology. So it first described by Dr. Michael Gries, the concept of digital twin technology in University of Michigan in 2002. However, actually, digital twin technology has been started used by NASA back in 1970, where they tried to fix a damaged Apollo 13 spacecraft in 1917. So because of this spacecraft is located in the space, so they use digital twin technology to create a virtual model of Apollo 13 spacecraft and do some correction or operations. And they told the crews to do this kind of corrections to the physical spacecraft out there. So basically they actually use digital twin technology unconsciously. Yeah. Okay, so the benefits of digital twin technology. First one is high accuracy, because it replicate the data from the physical system. So next one is drive sustainability efforts. It can be used for applying sustainability efforts to the models. And then third one, it can be used for a large scale projects such as cities, for example, a campus, and oil rigs for other sectors, spacecraft, and etc. So fourth one, to drive operational efficiency, also to offer insights to gain operational efficiency and different data sets to capture real-time information on asset and its performance. Basically, how the physical objects works, so we can see the real-time information through digital twin technology. Okay, the fifth benefits is it's very time-saving, because for example, in a city-wise, if we do a simulation for a city which is consists of many buildings, it will take lots of times, right? So this digital twin technology is very time saving, because we can simultaneously do a simulation on several buildings at the same time. Okay, then now we go to further into ICL. So what is it? ICL actually is Intelligent Communities Lifecycle. So digital twin technology for decarbonizing any built environment in this world. Okay, so before we go further, I will show you a video, an introduction video of ICL, and then I will explain further in the next slides.
Over the past 2 decades, IES have delivered digital solutions that substantially reduce energy use within the built environment. Today, the need to decarbonize to net zero is more urgent than ever. So we have been working to understand how digital twin technology can deliver zero carbon buildings and cities across the whole life cycle and the whole world. The ICL Digital Twin is a single interactive 3D solution aligned to the 5 key stages of decarbonization. Interrogate-ready data for quick wins, advanced data analysis for low-cost upgrades and retrofits, a physics-based model for the deployment of major energy-saving investments, simulates around buildings to create local energy networks, and create energy demand profiles to make easy renewable investment decisions to reach zero carbon. When manage your ongoing zero carbon energy efficiency in real time. IES's unique thermal simulation software can predict the performance of buildings, taking into account many variables. Real-time analysis using machine learning and AI is then linked to this physics-enabled simulation. The end result is a digital twin that responds exactly as your building would in the real world. Data inputs take the form of operational level dashboards and command centers combined with public engagement and communication platforms. However, it is the live interactive 3D model possible by a digital twin that really delivers standout benefits. IES was contracted to deliver a living lab on a 250-hectare eco-campus for NTU Singapore. Their goal was to reduce their energy, water, and waste footprints by 35% by 2020, and in the process, become the greenest campus in the world. Our digital twin revealed a 13% potential reduction in energy consumption and 4.75 million Singapore dollars in cost savings. Fully scalable from a single building to an entire city, the ICL Digital Twin delivers significant capital and operational savings from ensuring your master plans are energy and water efficient while taking socio-economic factors into account to reaching zero carbon and healthy building targets when you design or retrofit, into operating all of your buildings as efficiently and comfortably as possible, while maximizing potential of renewables, community energy schemes, and demand response, all with an eye to collaboration. Digital twin technology helping create zero carbon built environments.
Okay, so basically that video already explained everything about IES ICL, but I will further explain in the next slides. Yeah.
Over the past.
Okay, so first and for all, why do we need to have IES ICL in our sustainable master planning? First, it is actually an issue of rapid urbanization in the world and in Malaysia as well. So the urban population in Malaysia in 2021 itself is 77% out of the whole Malaysia. So in the world itself, 56% of people actually living in urban areas as of the year of 2020. So that's a lot of percentage and number. So basically, when there are lots of people living in the cities, there will be an increase, the rising of human activities, because urban is where all of advancement technologies and activities happen in the world. So also in Malaysia, it is expected to rise the urban population by 90% in 2050. Okay, so the carbon emissions actually in Malaysia, we calculate it using carbon emission per capita. Our rate is actually 7.6, which is actually quite high in my opinion, because China, which is the main consumer of carbon production in the world, it has carbon emission per capita data of 8.4, so 7.6, so it's actually quite high compared to other neighboring countries such as Thailand 3.8, Indonesia 2.2, and India 1.9. I think the main reason for this is because our electricity generation policies that mainly use fossil fuels such as the coals and natural gas for electricity generation. So 142.2 billion kilowatt hours the electricity consumption for Malaysia in the year of 2020, if I'm not mistaken. So 35% of the energy comes from the building sector, which is mainly in the urban area. So 80% of carbon emissions comes from urban setting, which equivalent to 200 million tons of carbon dioxide equivalent. So therefore, we already know the issue of how to reduce carbon emissions, which is the buildings and the cities. It has the greatest potential to make an impact in reducing the carbon emissions. But how do we do it? That's why IES developed the ICL, where a software can try to make use of buildings and cities to minimize its energy use and further making zero carbon targets in a realistic way. Also, they want to ensure that everyone is involved in its conception, design, and management. So that it's not just the responsibility of the governments, the engineers, or the architects, but the public as well will involve in managing their electricity consumption. Okay, 5 keys to net zero carbon. IES actually already make a calculation on how we can get 100% carbon savings from buildings. So 50% carbon savings come from behavioral and operational changes, which is the community of public works. Basically, they want to enhance a good behavior for the publics to consume electricity responsibly and use better energy savings appliances if possible in their own houses. Another 20% carbon savings come from this simulation physics enable simulation to support decision making, basically the works of engineers or architects. And then 35% carbon savings comes from 3D baseline modeling and investment of road mapping. So this is where the sustainable master planning of city, for example, comes. And 50% carbon savings from local energy sharing and demand management. Another 15% is from virtually test on-site renewables and low carbon tech. So this virtual test on-site renewables is where the simulation allows us to test the solar PV potential in terms of city or campus. Okay, so how ICL works? The first is the data input that available in ICL software. So the building, the BMS, and the terrain, smart meter, IoT sensor, weather station. So they have various tools that will help to input the data from Beam for Apache and other systems such as for renewable wind turbine, the EV charger, the solar data. So all of this is included in ICL software. So that's where IES Digital Twin comes from. Artificial intelligence, physics-based simulations, and machine learning. So the data output.
Zika, can I ask a question at this point? I hope.
Yes, sure.
The data input, are they real-time data using IoT to supply into the digital twin?
Yeah, actually, there are a few of other softwares. For example, I mentioned iScan. So iScan actually for NTU Singapore University, they put sensors in the electrical appliances such as boilers, if I'm not mistaken. So let's say that sensor detects some error in operation or some error that will increase the energy consumption of that boiler, for example. So we as the operational manager can detect the real-time data from that boiler. So we can detect, oh, there's an error here. And they can make some correction for that boiler, like that. Okay, Doctor.
Okay, thank you.
Okay. So from then, the data output will be presented and can be shown in the dashboards and command center of where the client and stakeholder can access the data. So this dashboard and command center is where they can see the real-time data of the physical objects in a virtual sense. So public also got some access in this IS digital twin operation, which is the Living Lab, community information, and also application apps. For example, I think in Malaysia, Dr. Lim, my supervisor, he has created a web link applications that actually shows the data of energy consumption of all hospitals in Malaysia in collaboration with Minister of Health of Malaysia. So if we click that link, we can see the energy consumption, the energy data of all hospitals. But I think it's still in an early stage because not all hospital, we still didn't get all data from all of hospital in Malaysia, just a few data only. Okay, so ICL digital twin tools. Okay, this is the sub software. We can see at the below of the slide, VE, ICD, IVN, iScan, and also collaboration cloud. So these 5 tools is what combines in ICL digital twin. So this aim, hit zero carbon target, it has unique technology, multiple data sources, and interconnected system. Okay, so I will expand a little bit on each of these softwares. So VE, okay, VE is ISVE is actually just like any other energy building simulation such as Energy Plus or Sphera. So VE is equal as those softwares where architects and engineers use. It just try to do a simulation to reduce carbon and energy of a buildings. For example, okay, this image actually show the daylight performance of Mercu Mustafa Kamal office in Kuala Lumpur. So it just do a simulation of where the lighting level that is perceived to be for the consumers in the building to gain during the day. Okay, and then ICD is where sustainable master planning occurs, where we can actually generate a city in a SketchUp actually. So ICD is actually a plugin in SketchUp, so we can create a model of city in the SketchUp and then do some master planning on how to reduce energy consumption and carbon emission from that city. Okay, the next one is IVN. IVN is a sharing platform. Okay, so basically everything that the data that we get from the VE and the ICD before, we can upload it and share it with the client or stakeholders in IVN. So that's where the operational manager can see or the public can see which part of buildings actually has the highest energy or something like that. So if you can see the third image on the right below of the slides, that is the simulated total energy of all the offices in located in Penang, Malaysia. So we can see there's a few companies building that has green indication, which shows that there's quite low energy consumption, and several, actually a lot, actually companies has high red indicators. So means that they use quite high energy consumption yearly. Okay, the next software is called iScan. So iScan is for optimal bidding operation. This is also basically for operational management, where they can detect if there is there is some appliances or there is some defect on the electrical appliance in certain buildings or campus or a city. So you can detect if there are a fluctuation in electricity demand on certain appliances daily, and also it can we can see the graph of the electricity consumption. Okay, the last one is collaboration cloud. So collaboration cloud is something that actually accumulated all of the other 4 softwares before this. Okay, so it has iSIM and iPIM. So ICD and VE software is for iPIM. iPIM is building portfolio that has data patterns, map connection, map resource, and monitor progress towards sustainability goals. So this is the job of the purpose for stakeholder, for architects, and for engineers to see the progress of the project's sustainable goals. Also, we can detect the worst performance as well. As you can see there in the image, we can see one building that has a red indicator. That means it's the worst performance. Okay, then the rest. So iSIM is for community use, where community is public. So therefore, they will, maybe some of them are not familiar with energy data and management, so they need a visual. So iSIM provides visualization for the energy consumption of its city, for example. So they can see which building has energy and resource energy consumption and the carbon production of certain buildings or their city wholly. Okay, ICL is one for all. As you can see here, VE for energy assessment, ICD for a larger scale sustainability modeling, and iScan and IVN is for networks and dashboard and display of the energy data.
Zika, can I ask something?
Yeah.
Where has this been done? Because to have this, you would require participation from they have to submit their data to a center where the data is being processed and analyzed and reported. Are they like required to submit the data to the local authority, for example?
Okay. From what I understand, actually in our project, so let's say I do the ICD works, and then I can submit the data of my ICD, the Batam City energy data, to the IES officer in charge. So he will upload the data of my ICD into the iScan and IVN. So in that website, so all the data from my works will be displayed on the dashboards. So the public can get access through the website.
So that means, is it voluntary? That means because you submit, they can use the data lah. But the example you give in earlier slides, can you go back one slide? Okay. No. Okay. That groups of building, is it a real city somewhere in New York, or because it seems that a lot of buildings participated in that
Yeah.
data.
Actually, actually IES is very quite such as overseas countries such as Manhattan City. This is Manhattan City. So they already use this ICL to generate energy data of Manhattan City. So this is an example of
So is it requirement by law that they have to submit the data to IES? Otherwise, I think if we ask companies to do this, they would say, why do I need to give this data?
yeah. Actually, other countries, they have a policy that companies or buildings need to submit their carbon and energy portfolio reports to the authorities. So I think that's where they get the information data.
Yeah. Because
all these
otherwise,
buildings.
if you wait for volunteers, they would not.
Yeah, it will be very difficult to gain all the data. Yeah. So I think Malaysia also can take example from these countries lah. Yeah. Okay. Okay, I'll show you a video on Glasgow Pollock Country Park. This is like a case study that make use all of the softwares in ICL. Okay, for your further understanding.
This is Glasgow, Scotland's biggest city by population and a place that's used to facing big challenges. Now it's set itself an ambitious target. Glasgow's aim is to become net zero by 2030, meaning it'll have to cut right back its carbon emissions and offset any that remain. In a city full of old buildings that aren't exactly known for their energy efficiency, that's not going to be easy. And yet, one new project is showing what can be done, using technology with IES to turn one of Glasgow's most historic sites into a hub for clean renewable energy that operates off-grid. That site is Pollock Country Park, the largest green space in the city and home to a number of iconic and important buildings. There's Pollock House, the ancestral home of the Maxwell family, and the Burrell Collection, a world-class art gallery. Next to it is the Merryhead Lodge, constructed in the early 1900s, and down by the river is an old courtyard and sawmill, which is being rebuilt as a new heritage centre. Completing the lineup is the Centre for Training Police Dogs. They might all be close together, but these buildings are all very different, and using the same methods to upgrade them simply won't work, as the IES team discovered. Pollock has the courtyard can give us the buildings which need to quite limited in terms of the difficulties of installing buildings. It's not just the exterior system, it's also the interior. But that doesn't mean that heating and lighting systems can't be considered, like the high efficiency condensing boilers and low energy LEDs that recently been fitted at Pollock House. But the more modern Burrell Collection doesn't have to adhere to such strict rules. The centre was recently given a £68 million refurbishment, which saw it reduce its heating demands and install photovoltaic panels. It's also equipped with systems for ventilation and dehumidification, which can use a lot of energy, but they're vital for running the city. In fact, over 2/3 of our energy use comes from just this one building. Local council decide how to update these structures so they're compliant with net zero. IES has assembled a digital twin of the whole site. A digital twin is a virtual replica of a physical asset, which can be anything from a single object to a group of buildings like a Pollock Park or even a whole city. In this case, physics-based digital models of each structure have been created, populated with live data of their energy use and carbon output. IES Virtual Environments, the company's flagship software for simulating building performance, was used to make digital twins of Pollock House, the Burrell Collection, and the courtyard.
Our core software is for the ISE, the Virtual Environment. It is in the market since 28 years now, and it has been used so far to design efficient buildings worldwide.
The Merryhead Lodge and the Police Dog Training Centre, IES's master planning tool ICD was chosen.
We have the ICD, Intelligent Community Design, which is our master planning tool, which allows us to create models of like the master plans, group of buildings, communities, cities, and it has been used in the park to create the model of the park.
We already had a lot of moving data that we're able to plug into the geometry of the model and have a very accurate, almost calibrated model of the Burrell Collection ready to go. Once the baseline of the estate's energy consumption has been calculated, implemented, IES plotted a number of scenarios highlighting how and where improvements can be made across the park. Each scenario shows a different level of upgrades and what the effects will be, giving users several options to work with. 5 different scenarios are modelled just for the courtyard, from simply installing electric heating systems to having double glazing, insulation, heat pumps, and a hydroelectric turbine powered by the river. Overall, the results showed that if all the possible changes were made across the estate, it would lead to a 34% reduction in carbon emissions.
Another tool that was really key in this project was the intelligent vehicle network, the IBN. This is a tool which allows us to create digital twins of an energy network. So basically, it allows us to analyze the supply and demand between different buildings. So this was really key in the past to understand how the renewables could be deployed and how the different buildings could exchange the resources.
Complete decarbonisation of the building's heating demands could also be achieved by interconnecting all of their electrical and heating systems. On top of this, 4 megawatt hours of battery storage and 3,000 square meters of solar panels will be needed to achieve the goal. This is the investment term, where is to become better operators when it comes to managing energy. Not just the designing sector, but operating and optimizing the energy flow. What's really interesting to me is the role of small scale renewables as part of that mix.
Zika, ada caption ke? Sebab dia tak berapa clear sangat lah.
Sorry?
You can turn on the caption ke? Ada caption ke? Ini bukan YouTube kan?
Oh, this no, I didn't upload with caption.
Okay.
Yeah, sorry.
Alright. Okay, tak apa. Sebab dia punya audio dia tak berapa clear lah.
Oh, not very clear. Okay.
Tak apa, carry on. We got
The final phase was the creation of live dashboards for displaying the data and results using IES's online data analysis platform, MyScan. It allows information on the building's energy use and carbon output to be viewed at a glance or in detail depending on who's viewing it. Vast amounts of data can be easily processed and understood, and that's crucial to making a project like this work. Transforming a site like Pollock Park to net zero is a big challenge, and it's one that cities around the world are now having to face. But with digital twin technology to hand, it's a task that can be made a lot more manageable.
Okay. I can share the links and the all the information from this slide to Dr. Zaki after this, so you can like hear it clearly after this.
Okay.
Okay. Yeah. Okay. So now my research paper is focusing using ICL-ICD. It's my methodology for the digital twin technology of Pertam. So I will show you a bit the demo on how to use ICL-ICD for sustainable master planning. So in this ICD, the components that makes ICL-ICD is it has a geography and topography tools where we can get the geolocation data of the buildings or the city. So the massing and form of the buildings, we can control or change or play around with the different types of envelopes, lighting sources, what else? The insulation and so on. There's a lot. Okay, and then we can do a simulation and gain its energy analysis, its water analysis. Also, we can put some renewables energy such as solar PV, or in the previous case study of Glasgow Pollock, they use hydroelectric for its alternative energy. So in terms of Malaysia, we put on solar PV, so we can gain the solar potential of the city. So it also can check the socio-economic impacts, basically on how many reduction of management or operational costs that we can gain. And then zero carbon plans, active travel, which is transportation, and also electric vehicles. This is basically the PV charger for electric. So we can also put a PV charger in our city and try to check how many energy that we can save from that. Okay, so first and for all, we will try to import from GeoMap. So I'll just show you the pictures. So first, import from GeoMap. In the GeoMap, we can write down the location of the city that we want to do the project on. So in this case, it's London. And then it will upload the data, the geolocation data and maps of City of London into the SketchUp. So this is the London Digital Twin City. So it's very basic, and it just has a geolocation data of the city. Okay, and then for each object, we can control its appearance or its envelopes. For example, we can edit the objects of each of the buildings. So for these buildings, we can control its height. So if we have let's say we use a Google map, and then we can see each building's height. That's my methodology lah, by the way. I go to Google Map and then I look for each of the buildings, the height or its type of roofs, for example. Okay, so the glazing ratio, and then its assumption of building height, for example. So we can try to control that envelopes of the buildings. Okay, besides that, we also can control its building envelopes, such as its windows, the doors, the type of floors, roofs used for its insulation. For example, for this time is glazing type for the windows. So there has a lot of options for each type of intervention. For windows, they have triple glaze, double glaze, single glaze. So each of this type has a different heat transfer values that we can play around. For example, let's say we want to try to see the reduction of energy. Okay, so on the baseline, we use the windows with single glaze, which has a higher heat transfer value. Okay, and then we do a simulation, and then we get the energy consumption of that building. So after that, we will try to change the heat transfer for the windows. We use type of windows double glaze, which has a lower heat transfer value. And then we do a simulation. So we get a new energy consumption for that building. So we can gain the energy reduction for the building. Okay, also, you also can control its HVAC service and also its water fixtures. Okay. Besides from that, we also can create objects into the virtual models. So for example, there's a few of buildings missing from the generation of the city models. So we can create the new buildings into the city. It's not just buildings, so you also can add things like trees, street lights, EV chargers, landscape, road, parking bay, and etc. Because all of these little things actually affect the energy consumption of the whole entire city. For example, if we put tree on the perimeter of certain buildings, so it provides shading for that buildings. Okay, so that shading is actually will lower the energy consumption for that specific building. So it will bring a different energy consumption rather than there's no tree alongside the building. Okay, after we already control or set the specification for all of the cities, so we can do a simulation. So this is simulation launcher in ICL ICD. You can actually simulate up to I've tried 20 buildings. We are talking about a city, right? A city has like hundreds or thousands of buildings. So if you think realistically, we can do a simulation for the whole city. Like let's say 1,000 buildings in one simulation. However, it will take quite a long time, and you need to have a very high or super laptop or computer for that. So in my case, I can simulate up to 20 building houses in one time. So it actually saved quite a lot of time. In 2 weeks time, I already done the simulation for the whole city of Batam. Okay. Okay, next is the simulation result. Okay, after we do simulation, so where to check the result of the energy consumption or the lighting energy, and etc. So in edit objects, there is a section where we can see the simulation of annual water, annual auxiliary energy, cooling energy, heating, carbon, and everything that we set before. So all the data is in edit objects. Okay, for visualization, we also can see a report gallery. For example, in this case, there are full site report, full energy report, full water report, carbon report, and renewable energy report. So we just click on any type of report that we want, and then it will show you graph charts of the energy consumption, or the energy use intensity distribution for the selected buildings that we want to see the report of. For the whole city, you just select all of the buildings in the city, and then it will show you the reports of energy for the whole city. It also has energy breakdown per category. So for example, on the image on the bottom left, okay, there we can see which sector actually use the most energy. For in this example, Giraffe heating energy uses the highest energy from January, February, March, November, and December. Okay, so in Malaysia, basically, the cooling energy sector use the most energy for cooling sector. Okay, and then this is also another type of visualization that we can use in ICL. Okay, so the colored building shows that building's already been simulated and already has the energy consumption or energy data. So the grade one hasn't been simulated yet, so you need to do a simulation for those buildings to get the data. And then here at the dashboard, the classification of the buildings, we can see the different classification. For example, there's school, single family, hotel, office, parking garage, or etc. So all of these things, we based on what type of settings that we did in the edit objects before. So if we set that building is a hospital building, so it will show all of the data of all the type of buildings in this visualization. Okay, so next is my case study for Batam City. So Batam is a city located in Kepala Batas, Penang, Malaysia. Okay, with GFA of 3.66 kilometers squared, population of more than 200,000 people. Okay, so I've completed a digital twin city for Batam. So this is the So this is the digital twin city. So because Batam city is quite a new city, so there's not a lot of high-rise buildings in Batam. Mostly are residential sectors, houses, and then institutional sectors. There's a lot of universities, high schools, and also there's an ILP in the city. as you can see there, there's a lot of terrace houses in Batam. Okay, so that's it. Okay, so my target in my research paper is this is from National Low Carbon City Master Plan, our government master plan in reaching sustainability master planning for cities. So actually Seberang Perai City Council is included in this project, which is target cities. By 2030, it will achieve 33% reduction in its GHG emission. So that's my goal, which is to reduce at least 33% of carbon emission. By 2040, 66%, and by 2050, the whole city will achieve carbon neutrality. Okay, this is the overall digital twin Batam. Okay, so my methodology is I do several scenarios to do simulation on the digital twin city. So the first one, scenario one, is the simulation to get the baseline data, total estimated city energy performance and carbon emission before any energy saving measurement is applied into the city. Okay, and then the next scenario, I will try to lower the U value of the building envelopes. For example, the windows, I will use a lower U value for U value building materials for the windows, for the roofs, walls, floors, and others. Okay, and then I will do simulation and get the data. Scenario 3, I will change the HVAC system for the whole city. This is more like assumption. Okay, converting the HVAC system for better energy performance. The scenario 4, I'll try to apply solar PV on the roof of a residential sector in Batam city. So we can see the potential and electricity offsets from the PV panels. And then the last one, I will just add on all of the energy reduction from the simulation of all these scenarios and see the estimated total energy savings and carbon reduction after all this optimization. So the baseline data that I get from scenario 1, building use energy intensity average for the whole city is 253 kilowatt hour per meter squared, and then energy consumption for the whole city is 928 gigawatt hour, and carbon emission of 479,123 tons of carbon dioxide. Okay, so and then I try to see which sector actually has the highest energy demand. So because we are living in Malaysia, so I already assume cooling energy will be the highest energy demand sector, which is proven true with 334 gigawatt hour. As you can see in the bar chart there, every month the cooling energy uses the most energy next to auxiliary energy. And then for the zone, it's residential zone. So how do I get the data for these zones? So if we set the buildings for example, it's a single house, so it will be in a residential zone. This software also can classify the buildings to different zone, residential zone. So if we edit the buildings as school or university, so it will be in the institutional zone. Same goes to hospital for healthcare, and then if shops, it will be under commercial, something like that. So for Batam, the residential zone, which actually covers almost 50% of the Batam city, so it becomes the highest energy consumer in Batam city, followed by commercial and institutional. Okay, for scenario 2, I try to lower the U value of all the buildings in Batam city. So that graph shows the changes that I made through to the building envelopes of all the buildings in Batam city. So the first one, the scenario 1, is the baseline. Scenario 2 is the lower U value. Okay, so total U value reduction from this scenario I did is 10.01 or 49%. from the scenario 1, the baseline. So I do a simulation and I get 132 kilowatt hour per meter squared for its BI, energy consumption of 848 gigawatt hour, carbon emission of 134,075 tons carbon dioxide. So there's a slight reduction in energy and carbon. Okay, next I do a scenario 3, which is HVAC system optimization. So in scenario 2 and scenario 1 as well, I set the HVAC system as VAV indoor package cabinet system. So in this scenario 3, I try to use fan coil system. Okay, and I see the reduction of from 848 gigawatt hour to 715 gigawatt hour. So energy saving percentage from this simulation, from this optimization is 15.7%. Okay, so even the cooling energy still becomes the most energy demand, but it has been reduced slightly from the previous scenario. Only 177 gigawatt hour. For this, it's 334. So there's a slight decrease. Okay.
Can you go back one slide?
Yeah.
Okay, so in scenario 2, you use a variable volume, and in scenario 3, you use the fan coil system. Are they exclusive? I mean, are they, when you put fan coil system, you don't use VAV anymore? Or
yeah, I didn't use the VAV.
3 on top of scenario 2.
Sorry?
So you mean you change in scenario 3, there's no VAV, you just use fan coil
system. Yeah.
Oh,
Yeah, correct. I changed the HVAC system for all the buildings in Batam. So assumption they all use fan coil system, HVAC system.
So you're saying that fan coil system is more energy efficient than VAV?
From the simulation, it's proven yes.
Oh, I see.
Yeah, I actually in ICL there's a lot of other type of HVAC. So I think almost 20 types. So I already do simulation for each of the HVAC system, and considering we're living in Malaysia, some of the types of HVAC is not applied here. For example, radiant cooled ceiling, which is very rare. So I didn't use that. That is, I think, the most good HVAC system. So I choose the next one is fan coil system. So that's why I apply it.
Okay, thank you.
Yeah. Okay. So the next one is scenario 4, where I try to calculate the potential solar PV contribution. Okay, so in this case, there's a bit of what we call technical difficulties for me, because I do the simulation in a laptop. So I couldn't generate a solar PV panels for the whole city of Batam. It requires a very high CPU data. So my laptop basically cannot cater with those kind of performance. So I just put solar PV in a small type of residential sector, as you can see in the image. This area is 0.324 kilometers squared. So potential solar PV area, which is the amount of solar PV panels, is 0.06 kilometers squared. So on the roofs of the houses. Okay, and then I try to do a calculation to estimate the energy consumption of Batam. So that is the equation. So and the pie chart shows that is the data of energy offset for this residential area. Okay, as you can see there, the emission offset by PV is about 7,623 tons of carbon dioxide. Oops. Okay, and then the PV contribute 14.7 gigawatt hour. So there's a balanced electrical energy of 33.3 gigawatt hour. So I use this data into the equation. So estimated energy use in Batam now has been reduced to 536.6 gigawatt hour. Okay, so this is basically an assumption just from this small area of residential. Okay, so this is the solar PV potential on the roofs of the residential houses. So it's not covering the whole house, the whole roof area of the houses, because there might be shadings or sun angle. So those areas are not appropriate to put solar PV panels. So this software has already calculated which side of the roof is actually will gain the best solar. Okay, so the conclusion, the analysis of potential energy savings and carbon reduction for Batam City. So from 928 to 848 to 715 to 536.6 gigawatt hour. So there's a reduction of 8.6 from scenario 2, 15.7% from scenario 3, and solar potential 24.95%. So that's mean actually the usage of renewable energy to cities or some buildings actually has the highest contribution in reduced energy and carbon. So now total energy savings and carbon reduction of Batam is 49.25%. So that means I already exceed my the target goals of 33% reduction of energy consumption based on the National Low Carbon City Master Plan. Okay, yeah, that's all for me. Thank you.
Thank you, Azika. Very interesting presentation. I hope that our students will start to grasp the importance of such technology, that we will start to think about this. And I believe in the future, very near future, all these are available at a very accessible cost to most professional users. So it is something that that we need to think about. I would like to open the forum to any question from the students. If anybody has any question, please. No question? Everybody in the know? Okay, let me start. Can you share the screen again, Hazika?
Oh yeah, sure. Okay.
I'm not sure which particular screen we are looking at, but just give us the idea of what we are looking at. One of the question I have in my mind is in the Batam case, right?
Okay.
Like a real life monitoring, right? It's solely a simulation scenario. Because you don't have access to all the inputs from all the in the Batam area yet.
Yes, correct.
So in this case, it's not used as a monitoring platform, right?
Correct. This is
It's
just
more
for estimation of energy reduction and carbon emissions.
okay.
Yeah, there's a lot of other things that can be done to this project.
Okay. What about emission from traffic? Have you had the opportunity to look into that?
Yeah, not yet, because for this research paper, I focus on the buildings of in the Batam city only. Yeah.
Okay.
So actually, if we want to do digital twin city, it will consist of the roads, the transportation, and other things. But in this case, I only focus on the buildings.
See.
Yeah.
But it is capable of doing transport emission, right?
Yeah, it's possible actually.
I'm just wondering if you want to do transport emission scenario, how do you get the data for that if you are doing live real-time data, because for buildings, you can get the input from various sensors, the electrical meters, all the
Correct.
sensors. But for traffic, how do you do that?
I think I'm not qualified to explain about it because I didn't.
Yeah.
Yeah.
Is-
If I ask for, with the IES officers, I think yeah, he can provide me some insights on the transportation parts.
Yeah, I think that is another interesting scenario, because I can imagine that the energy, the transport emission itself alone maybe can be half of the energy use of the whole Batam area. I don't know.
Yeah.
Question,
that's
guys? Are you all listening or not? Are you there? Because I don't see any live faces on the video. Questions? Anybody?
Okay. So maybe they understand well.
Oh, okay. One question. Is the software free?
Oh, is the software free? No, of course not. I'm not the IES sales and marketing officer, but in this slides, I know I promote the IES very well, but it's not free. There's quite it's quite expensive. So maybe
They don't have
can
like students version of the software, is it?
student version. No, I don't think so. Yeah, I don't think so. Maybe UPM can get some grant for installation of this software. Probably.
Oh, if Sri want to make money, Sri can give the software.
Dr. Lim actually asked me to ask you to buy this software for the students actually.
Okay, they have just learned IES,
Yeah.
So maybe for the next cycle, we would consider of doing this, but this would requires a group effort, because normally when they're in a group, they look at a larger area. When it goes down to their individual project, they are looking at individual buildings.
Yeah, correct. For individuals, I think they can do the simulation for individual buildings, maybe hospital complex.
I see.
So,
even using ICL.
Even using ICL, yeah.
Oh, that means you don't need IES for individual building anymore.
No. That means if we do the digital twin for hospital, so we will use the ICD and then the VE as well.
I see. Okay.
So it's still applied to complex like that lah.
Oh, okay. I mean, it's like the individual building is like a plug-in to the ICL, is it?
Individual buildings of the hospital.
Yeah.
Yeah, correct.
It's like a plug-in.
This one, yeah, plug in this SketchUp.
I see. All right. Okay, guys. Any other questions? How is your individual buildings in IES coming? You haven't finished that yet, and now you are listening to something new. I believe this is very, very new in Malaysia. I posted many years ago of doing almost like a SimCity.
Yeah, kind of like slap playing with.
The engine is already available in the market. It's just that no research has been done to actually turn this into scientific tools. But it's very interesting, and IES had done it. I think they did an amazing job of doing this simulation, doing this package. So it's something you guys can look forward to when you go into the market. This might even create a whole new profession.
Right.
It is something special. You need some sort of skills and knowledge, a little bit of background understanding of how energy interplays in a building, and especially in the city. So who knows, you might want to venture into this. Very interesting.
Yeah. Maybe energy advisor for
Energy
companies.
advisor.
Yeah.
When you guys architect becoming turns into energy advisor, you have the advantage of the design thinking. You are not thinking about only the scientific aspect of reducing energy, but as an architect, you also think about the wholesome scenario of designing a settlement of residential and development for human. So that is something that maybe you should look forward to. Any other question from the floor?
I think I want to add one thing. Let's say that there are other students actually interested in discovering this IES. You can go to the Google and website www.isbe.com. Okay, and then from there you can gain a lot of information that you need on ICL. There's also a lot of case studies that has been done by IES teams.
When was this developed?
IES.
No,
IES actually.
The ICL.
ICL. I'm not sure, but it's quite new. I think in under 10 years.
Yeah.
Like that.
Because when I started thinking about this, there were no such software yet. Think of SimCity to.
Yeah. There's also a trial web demo, maybe that if others want to try to explore. Yeah, all under that link.
Okay. So Azika, you are in which semester now?
I'm in semester 3.
Semester 3.
Yeah.
Basically, you have done all your data, the data collection.
Yeah, correct. Basically, the simulation is done. I already gain all the data needed, so I just focus now on writing the thesis and dissertation. Yeah.
Okay, are you thinking of turning this into your PhD study?
Inshallah, it's in my planning.
Okay, there's a question from Michelle. Hi, good to meet you again. Oh, have you met her before, Michelle?
Yeah, from sorry, the competition before.
Oh, okay, all right.
Yeah,
okay.
that's
That.
Yeah.
Is this program can be applied to a site before it has been designed and developed to obtain the data for sustainability for development? So the question is, can you use this software for simulating a scenario, development that is not being built yet?
That is not being built yet. Yes, of course.
Yeah. Yes.
I think it might be quite easy. Let's say you already has a specific location that you want to develop a city. Okay, so you just download the geomap from the ICL. So we have OpenStreetMap, which download the terrains, the location data, and then you build your own building, create your own buildings on the terrain. So it will also can simulate the estimation of energy based on your settings on the buildings.
In fact, that is a very good question.
Yeah, correct.
Of this simulation is actually before you develop, because normally when it has been developed, all you have is try to mitigate, try to repair all the damage has been done.
Right.
Here,
and
yes. Sorry. You were saying something?
No.
Okay. And then you imagine like this, if you want to test the safety of a car, it's good before the car is being produced. You can do a dummy test, you can crash the car so that you can get the correct data, so you know how to design properly. It will be very difficult to try to improve the security after the car has been manufactured. Then you want to improve the security, then you realize, oh, you had designed it wrongly, but it's too late. You have already produced hundreds of cars, thousands of cars that requires modification. So the real value to me it's in the use of it before the project has been designed. That means you still can change things. You realize that the building should be arranged like this. You should group these buildings together instead of putting it over there. So I think that's the real value of it. Nevertheless, in many cases, cities are already developed, but you can also use this software to improve the condition of the city, the energy use, environmental emission of the city. Yes. Okay, any other question? Probably in the future, it will be, planners. They have to submit energy performance of development that they will, it will meet certain requirements. Okay, and this is where the education of planners itself now need to change. They need to understand the implication of energy use. Right now, only architects are familiar with how buildings are using energy, but planners, I don't think they have ideas of how energy being generated from a development, but they will have to understand this lah. Okay, or like I said, then there is opportunity for you guys to go into taking the role of energy advisor of planning. It's something worth thinking about. Okay. All right. Any other question? Okay, I just want to add that there are still 2 lectures I'm preparing for the replacement of those holidays. We have too many Mondays holidays this semester. Almost half of the semester is taken by holiday, so I'm doing a lot of online videos. So something I've been working on. I was hoping to put up the video before this lecture talking about heat transfer, so that you will know what is U value, that is in the lecture. But I had problem with my computer last week. I had done the recording and suddenly things gone haywire. I have to do it again. I need to upload that lecture again. So look up for the lecture on that. And okay, tak ada question lagi? Any other question regarding this? Can you just quickly go through the slides again?
Yeah, sure.
Okay. To refresh their.
Which part?
Okay. From here it's okay. Okay. After this, you can go to the beginning again. There were a couple of questions that I wanted to ask when you were presenting.
Regarding the Bertam or ICD?
ICD.
Okay. So basically, this
I want to see the component of the ILC, just the IES component that you showed just now. Okay. All right. Can you zoom on the boxes, the colorful boxes up there?
Okay, sure.
So on the VE, you have VE, right?
Yeah, this one.
Okay.
Sorry.
This is the normal IES package for individual building, is it?
Okay, yeah, correct. VE,
Okay.
energy simulation for building.
Yeah, so it is part of the software. So if you don't have VE, can you run LC?
No, cannot.
Yeah.
ICD.
ICD.
You need VE for ICD.
Okay. So guys, VE is the software you are learning now with Mr. Mahmood. Okay. So have that, then the engine will be used to calculate, to put data for all the buildings in your development, and it will generate the whole concept. Okay.
Correct.
iScan, what is it again?
iScan is for building operation, so can see very details on the appliances energy management system. Basically, as you can see there, the chiller. This is for operational energy data for chiller.
Oh, okay. So it's more detailed lah.
Yeah,
you just put in very rough estimation and VE, right? So now this
correct.
You have this, and IVN is okay. If you in renewables.
Renewables, yeah, of course. And
okay,
also
renewables.
sharing energy data.
Functional energy data. So that
Mm.
and ICD is
ICD is for sustainable master planning for the city lah. Mm.
it the model making part?
The model making part is in
Yeah.
here in ICD.
In ICD. All right.
Yeah.
Where you use, I imagine it's still use the same SketchUp engine to generate the 3D models.
No, actually, if you create a detail, because VE you can create quite detailed buildings, right? So you can actually import the buildings that you create in the VE into the ICD. So, but if you want to create a master plan of a city, there will be lots of work lah. So that's why ICD exists, because it just generate the whole buildings for city.
Oh,
like,
it's just develop massing, like one building is one mass.
Yeah.
Doesn't have the
correct.
zones.
We can set, we can do settings for the zones, because
Inside the building.
inside the building, yeah, we can do setting. Let's say
okay.
we set it as houses, so it will automatically become residential zone.
Okay, all right.
Yeah, correct.
Okay. And then the collaboration cloud is what is the server where the data is kept lah, where you exchange information with other users lah, right?
Yeah, betul, correct. Yeah.
So in the future, do you see that the city itself, for example, we are near Kajang. Kajang itself need to provide a digital twin. Who provides the digital twin?
For Kajang.
Yeah, but for example, if you want to do for Kajang or Subang Jaya or whatever, who would be the authority to take care of the digital twins? I mean, for not every architect can create their own version of digital twin, right? The digital twin must be just one copy of the real data.
Yeah, of the real city.
Yeah, I know that right now IES is apa tu? Handling the cloud for the digital twin, right?
Yeah, correct.
Like the case in Manhattan you showed just now, the 3D model is being kept by whom? I mean, I know by IES, but who controls the
whole? Okay. But I can speak in the case of Bertam lah, because that's where my project is. So the starting of this project is actually the collaboration with the Seberang Perai City Council. So the Adun himself actually wants to create wants to join the sustainable master planning of Bertam. So that's why Dr. Lim actually joined the project and start to do propose the digital twin technology of Bertam. So that's why he used IES as
so that means the digital twin was developed in IES by you guys lah, by you and
correct. So basically we control the operational and management. Yeah, correct.
Okay, good. Thank you.
Yeah.
Thank you very much, Azika. There are lots of questions, interesting questions can be asked, but I think the students still are new to the idea, even to the IES VE. They are still learning the concept, but guys, this is the future. Please
correct.
Understand, have a look at this. I would like to thank very much Ms. Azika.
Thank you. Yeah, also thank you.
And I hope we can see a lot of this, the progress of this in the future for the sake of our nation. It's a very important aspect of energy emission. So good luck and all the best to you. And Dr. Lim, send my regards to Dr. Lim.
Yeah, sure. Thank you, Dr. Zaki, for appointing me for today's lecture.
Okay,
and also thank you for all the students as well.
So guys, please do your best for your IES and submission of the assignment. That will be big part of your assessment for the course this semester. And please, I will update with you with the few more lectures I will record online. That is important for you to understanding further how IES, VE, and all these building simulation works. And next week will be another session with Mr. Mahmoud on IES. So if you have any question before we go off today, anybody, any question regarding the rest of the course? Tak ada, eh? Oh, everybody is so very productive. Okay. So with that, please sign your attendance. Thank you very much, Azika and everybody. Hope to see you next Monday. Okay. With that, Assalamualaikum warahmatullahi wabarakatuh and goodbye. Thank you.